Horizontal and vertical lines. Horizontal lines have equations of the form f of x equals b. Vertical lines have equations of the form x equals a. Example 6. Write an equation for the horizontal line graphed above. This line would have equation f of x equals 2. Example 7. Write an equation for the vertical line graphed above. This line would have equation x equals 2. Try it now. Describe the function f of x equals 6 minus 3x in terms of transformations of the identity function and find its horizontal intercept. Parallel and perpendicular lines. When two lines are graphed together, the lines will be parallel if they are increasing at the same rate, if the rates of change are the same. In this case, the graphs will never cross unless they're the same line. Parallel lines. Two lines are parallel if the slopes are equal or if both lines are vertical. In other words, given two linear equations, f of x equals b plus m1x and g of x equals b plus m2x, the lines will be parallel if m1 equals m2. Example 8. Find a line parallel to f of x equals 6 plus 3x that passes through the point 3, 0. We know the line we're looking for will have the same slope as the given line, m equals 3. Using this and the given point, we can solve for the new line's vertical intercept. G of x equals b plus 3x. Then at 3, 0, 0 equals b plus 3 times 3. b equals negative 9. The line we're looking for is g of x equals negative 9 plus 3x. If two lines are not parallel, one other interesting possibility is that the lines are perpendicular, which means the lines form a right angle, 90-degree angle, square corner where they meet. In this case, the slopes will, when multiplied together, will equal negative 1. Solving for one slope leads us to the definition. Perpendicular lines. Given two linear equations, f of x equals b plus m1x and g of x equals b plus m2x, the lines will be perpendicular if m1, m2 equals negative 1, and so m2 equals negative 1 divided by m1. We often say the slope of a perpendicular line is the negative reciprocal of the other line's slope. Example 9. Find the slope of a line perpendicular to a line with a slope of 2, b, a slope of negative 4, c, a slope of 2/3. If the original line had slope 2, the perpendicular line's slope would be m2 equals negative 1 over 2. If the original line had slope negative 4, the perpendicular line's slope would be m2 equals negative 1 divided by negative 4 equals 1 over 4. If the original line had slope 2/3, the perpendicular line's slope would be m2 equals negative 1 divided by 2/3 equals negative 3 divided by 2. Example 10. Find the equation of a line perpendicular to f of x equals 6 plus 3x and passing through the point 3, 0. The original line has slope m equals 3. The perpendicular line will have slope m equals negative 1 divided by 3. Using this and the given point, we can find the equation for the line. g of x equals b minus 1/3 x, then add 3, 0. 0 equals b minus 1/3 times 3. b equals 1. The line we're looking for is g of x equals 1 minus 1/3 x. Try it now. Given the line h of t equals -4 plus 2t, find an equation for the line passing through 0, 0 that is A, parallel to h of t, B, perpendicular to h of t. Example 12. A line passes through the points -2, 6, and 4, 5. Find the equation of a perpendicular line that passes through the point 4, 5. From the two given points on the reference line, we can calculate the slope of that line. M1 equals 5 minus 6 divided by 4 minus -2 equals -1 divided by 6. The perpendicular line will have slope M2 equals -1 divided by -1, 6 equals 6. We can then solve for the vertical intercept that makes a line pass through the desired point. G of x equals b plus 6x, then at 4, 5, 5 equals b plus 6 times 4, b equals -19. Giving the line g of x equals -19 plus 6x. Intersections of lines. The graphs of two lines will intersect if they are not parallel. They will intersect at the point that satisfies both equations. To find this point, when the equations are given as functions, we can solve for an input value so that f of x equals g of x. In other words, we can set the formulas for the lines equal and solve for the input that satisfies the equation. Example 13. Find the intersection of the lines h of t equals 3t minus 4 and j of t equals 5 minus t. Setting h of t equals j of t, 3t minus 4 equals 5 minus t, 4t equals 9, t equals 9/4. This tells us the lines intersect when the input is 9/4. We can then find the output value of the intersection point by evaluating either function at this input. J of 9/4 equals 5 minus 9/4 equals 11/4. These lines intersect at the point 9/4, 9/4, 11/4. Looking at the graph, this result seems reasonable. Two parallel lines can also intersect if they happen to be the same line. In that case, they intersect at every point on the lines. Try it now. Look at the graph in example 13 above and answer the following for the function h of t. A, vertical intercept coordinates. B, horizontal intercepts coordinate. C, slope. D, is j of t parallel or perpendicular to h of t or neither? E, is h of t an increasing or decreasing function or neither? F, write a transformation description from the identity toolkit function f of x equals x. Finding the intersection allows us to answer the questions as well, such as discovering when one function is larger than another. Example 14. Using the functions from the previous example, for what values of t is h of t greater than j of t? To answer this question, it is helpful first to know where the functions are equal, since that is the point where h of t could switch from being greater to smaller than j of t or vice versa. From the previous example, we know the functions are equal at t equals 9/4. By examining the graph, we can see that h of t, the function with positive slope, is going to be larger than the other function to the right of the intersection. So h of t greater than j of t when t is greater than 9/4.